Hi folks, I am solving Leetcode's top 150 questions and that's all you need for your coding interviews. In this video, we'll be solving 300 longest increasing subsequence. We are given an integer array nums and we have to return the length of longest strictly increasing subsequence. So what this means is we have this example here. If we can ignore our 3 or we can ignore our 5, we can get the longest subsequence. A subsequence can be derived from another array by deleting some or no elements. Here we are deleting either 5 or 3. Doesn't matter because the longest is 4. So the first thing that may come to your head is brute force approach, where we have got a two choice, either to include this or not include this. And we have got this choice on pretty much every element. So it will be 2 and this solution takes to 2 raised to the power n. But this is very inefficient. So let's take another example where we will use depth first search with caching. So if you can think about the decision tree that we will make here at every given point in time, it will look something like this. If we start at each of these indices, we will get 2, 3, 7 and 5. Now let's go down this 2's path. We have only got a choice to use 1, 2 or 3. So if we go for the first indices, it will be 2, 3, or if we go to the second indices, it will be 1, 7, and similarly for 5 as well. And now let's go down this path. So 2 and 3. Yeah. So there is one more case. If we go down this path, there is one more index that comes after 2, but that will be our 7 is greater than 5 and hence we won't use this. Now before going on these two, let's look at what happens if we go this route. So our third index is the last index here, right? So we can't go anywhere from here, but we do have our longest increasing subsequence at 3 as 1 here, because if we start at 3, there is only one element that we can add, and that's what is here. And isn't this what we learned over here as well? So at this index 3, we added this fifth element, and now we can't go down there because there is no element. And the same thing was shown by this second index, that we can only add one element. And hence we know from here that our longest increasing subsequence at 2 is also 1. And this statement right here, it says that we can't go right on this path. This will be cross here. What about this 1 here? We already had a 1 here, and no matter what we chose from here, we can say that either this could be this route or it could be this route. Either case, it was going to be 2 here. What about our 0? So from here, we can tell this could be either this path, which is 3, or it could be this path. So this at 0 will be our 3. And if you look at these right here, this is what we will return, the maximum of this, which is our 3 here. Now, if you think about it, our DP problem is starting from the last element and goes all the way to top. So let me clear this and let's discuss on the DP problem.